This cluster came out of an Audi A4 B5, the one everybody's grandfather had. The big display is full of artifacts. The small one is completely dead, no backlight at all, and someone has ripped the airbag warning light straight out of the board. A workshop quoted a replacement. That's what usually happens to these. We're going to fix it instead. We're Daniel and Andy, two power electronics engineers from Salzburg, Austria. By day, we build drivetrain and battery systems. The rest of the time, we take in the things everyone else already gave up on. This is not dead yet. Board level repairs, filmed start to finish. No cuts, no magic, and no hiding the ones we lose. This is our first patient. Let's open it up. These clusters come apart from the back. Clips just 2 screws, and the plastic is 30 years old. Take your time or you'll snap them. And there it is, the board out in one piece. You can already see the discoloration around the board, that peat, 30 years of it. We tried reflowing the display joints first. The artifacts are still there, so it isn't the connection, it's the glass itself, and no amount of solder is going to fix that. The display comes out. First step is lifting the flex off the board. Low heat, plenty of flux, and no pulling. These tear if you rush them. Then the pads get cleaned down to bare copper. new display goes in. Before anything gets soldered, it has to sit square in the frame. If the glass is off by 0.5 millimeter, you'll see it every time the cluster lights up. Pads are clean, so we tin them lightly. Then the flex gets aligned. Take the time here. Every contact has to land on its own pad, and there's no fixing that once the solder is down. Alignment's good, so we tack down both ends first. That locks the flex in place and lets us work the rest without it shifting. Then along the row, one pass, low temperature. These pads are thin and the flex doesn't like heat. Fine tip, minimal solder. Most of what you need is already on the pad. Last step is the microscope. Every contact gets checked for bridges before this goes anywhere near power. Before we go any further, this gets tested. Bench supply, low current limit, and we watch what happens. The rule here is simple. Test after every repair, not at the end. If you fix 3 things and then power up and something's wrong, you've got 3 suspects. One at a time, and you always know what caused it. Display's clean. No artifacts, no missing segments. That's one fault down. Now the broken trace. Now I'm not pointing fingers, but this doesn't look like it failed on its own. The airbag telltale has been pulled straight off the board and it took a trace with it. That's not heat damage and it's not age. Someone was in here before us, and that trace is interesting because of where it runs. My guess is this is what killed the small display. A broken trace looks worse than it is. It's copper. If you can bridge it cleanly, it's as good as it was. Scrape the solder mask back on both sides of the brake until you've got bare copper, then tin it. Short piece of wire across the gap, one end at a time. The mistake here is too much heat. Sit on it too long and the pad lifts, and now you've got a bigger problem than the one you came with. Clean off the flux, then continue to check. Trace it back. Trace is back, continuity checks out, so let's see what that fault is. Same routine as before, bench supply, current limit low, and we watch. confirms it. The trace someone tore off with the Airbag LED was the fault the whole time. One mechanical failure, two symptoms. Next up, the Airbag LED goes back on. Watch the polarity. It's a diode, so it only works one way round, and the easiest way to be sure is to check it before it goes anywhere near the board. Multimeter on diode test, and if it lights up, you know both that it works and which way round it goes. Then the same routine as before. Clean pads, fine tip, low heat, 2 joints and you're done. Before we touch the rest of the board, the repaired trace gets sealed. Solder mask lacquer over the wire and both joints, then cured under UV. Takes a minute. This isn't cosmetic. That trace is bare copper right now, and bare copper on a dashboard corrodes. Sealing it means the repair survives the next 30 years the same way the original did, and then we go over the rest of the board. Not because we found anything else, but because a cluster this old has been heat cycling every day for 3 decades, and that's exactly how cold joints start. With the reflow done, every IC gets checked pin by pin under the microscope. You're looking for two things: joints that didn't take properly and bridges, solder sitting between two pins that shouldn't be connected. Bridges come off with flux and clean braid. Touch it, lift it, done. No extra solder needed, it's already there. This step is not optional. A bridge you miss now is a short the moment this board sees power, and depending on where it sits, that can take out more than it came in with. That's it. All that's left is putting it back together. Thanks for sticking around this long. 20 minutes is a lot to ask on the first video, and I appreciate everyone who made it to the end. Quick note on submissions. The queue is full for now, so we're not taking free repairs at the moment. You can still register something at NotDeadYet.at. Tell us what it is and what happened to it, and we'll come back to you when there's room on the bench. If you got something out of this, leave a like and subscribe. And drop a comment. If you'd have approached this cluster differently, I want to hear it. See you with patient number 2.